Hello, good morning or good afternoon to you, depending on where you're joining us from, and welcome to today's webinar. My name is Chance Millett-Bangs from the Business Review, and I will be your host. It is our pleasure to have ECI Telecom with us today, who will be discussing network transformation, not as scary as it sounds. Today's guest speakers are Jonathan Homer, Director of Portfolio Marketing, and Gil Epstein, Senior Manager of Product Marketing. I'd like to welcome you to our webinar platform On24. This webinar is browser-based, so if you disconnect, please click the link that you received via email to rejoin the session. You may move and resize all the windows on screen to customize your view. All of the icons along the bottom of your screen are the interactive widgets that we have on offer today, so please interact with them all throughout the session. You can ask your questions by using the Q&A widgets or the questions box at the top left-hand corner of your screen, and we'll aim to allocate around 10 to 15 minutes at the end of the session to address any questions or thoughts that you may have. If you click on the green resource list widget, there is also an ECI company profile or company brochure for you to view or download at your leisure. There's also a brief survey to obtain your feedback on today's session, which is located in the red survey widget. Please use the help widget if you experience any technical difficulties or you require any more assistance. So, without further ado, please allow me to welcome Jonathan. Jonathan, over to you.
Well, thank you very much, Chance. Hi, my name is Jonathan Homer, and today with my colleague, Gil Epstein, we will conduct this webinar on network transformation for mission-critical utility networks, focusing on the energy sector. One point before I start, maybe just to overstate a point for clarity, when Gil and I use the term network in this webinar, we are always referring to a telecommunications network. Now, I am fairly confident that I am correct in stating that in the utilities world, the pace of transformation of legacy time division multiplexing or TDM networks to modern packet networks is taking place more slowly compared to the broader telecommunications industry. So before we get into the meat of the presentation, to help us gauge our common progress in this transition, we would appreciate if you would respond to this poll question on your screen. All the responses are aggregated, and only the percentages in terms of the responses are shown. So, the question is, have you begun the transition of your legacy transport network to packet? The answers, and you can just choose one, is yes, we have completed the process. Yes, the majority is complete. Yes, but we still have a long way to go. We have not yet begun the process, and other. So I'll give everyone about 20 seconds or so to respond because you can only do that while the screen is open, and then we will move on to the next chart. And I have one chart in between, and then we will review the results all together. So I'll give you another 10 seconds. All right, I think everyone should have made up their mind, so let's move on. So before we review the results, I'd like to review and summarize our learning objectives for this webinar. Our hope and our goal is to provide you with a better understanding of the challenges and the options that are available to you in modernizing to a packet network. We hope that by the end of this webinar, you should understand how to maintain the same degree of performance control as with your current or your previous TDM network, how to maintain and in fact improve network security, and how you can leverage network capabilities for revenue generating purposes, perhaps as a utelco. So now let's see the results of the poll question. So we have a bunch in the middle. I'm glad to see that 10% of you are complete. And I hope you're on this webinar because you're recognizing that as with any technology, you're never really truly complete. There's always the next go-around and improvements. But I guess that means that you're sort of mostly done. With the rest of you, a large percentage in the middle in terms of majority complete. And then actually the largest results still have a long way to go. and of course we have not yet begun in another. So this is a pretty even distribution. It's very satisfying for us to see that, because I think it means that we have something to discuss on this webinar, and certainly if any of you, as we'll say at the end, want to come back to us for more questions, we're always here to consult. So we look forward to this webinar, and let's get into it. So before we begin talking about the utility sector and telecommunications in the utility sector, we're going to spend a few charts outlining the changes that are taking place in the broader telecom world. This chart and the next one outline global communication trends and how telecom equipment is evolving to support them. It's important to understand these trends even for utility networks, because they do set the context from which you will draw your own solutions. What will be interesting, of course, is how you can shape these solutions from the broader telecom industry to meet the particular requirements of the utility industry. So we'll start in the cloud. Hosted applications living in the cloud are creating a surging demand for bandwidth, and they're shaping new, less hierarchical traffic patterns. This is driving a need for virtually unlimited and highly scalable transmission and switching capacity. Now, user and device mobility, with a desire to access services anywhere at any time, some people might call this eventually the Internet of Things, are translating into ever more complex multi-layer networks. This is driving a need for network efficiency to ensure that networks are both flexible and profitable. Now, service providers, telecom service providers, are seeking new revenue sources in response to the continued assault of over-the-top services from third-party content providers. In other words, just using the network for transport and not really getting any services from the network. This is driving a need for an open network that can be programmed quickly to create new revenue-generating applications. Now, one consequence of open networks and flexible services is that now networks are more susceptible to attacks from hackers. This is driving a need for heightened security of the network's operational infrastructure and the transport carrying paths themselves. So, how is telecommunications equipment responding to these drivers? First, equipment is becoming more scalable, with up to multi-terabit transmission speeds and transmission capacities, which translate into virtually unlimited bandwidth to satisfy any transport demand. Next, through flexible packet plus optical convergence, coupled with end-to-end service provisioning, we are seeing a new efficient base of transport equipment that features a low total cost of operation. A longer-term trend in the industry is towards network equipment with open control interfaces that support network automation and customizable user applications. This is something called software-defined networking. And this equipment is the basis for delivering smart, open, and programmable networks that create new revenue streams and also have the ability to lower ongoing costs through greater network efficiency. Finally, we are seeing the emergence of enhanced security appliances and applications aimed at preventing, alerting of, and quick recovery from hacker attacks to ensure true operational and transport cybersecurity. So, why are we here at ECI today to talk to you about this? And what is our experience in terms of these trends applying to utility networks? Well, the answer we feel fairly comfortable with is in our record of accomplishment. ECI is a leader and has been a leader in providing advanced telecommunication solutions for over 50 years to service providers, and as this diagram shows, to over 100 utility mission-critical networks worldwide. This includes customers in all continents with names such as Tenet, Amprion, RTE, REN, ITCHE, and CEPM. And we are very happy to share our insights with you today. I will now hand over the microphone to Gil, who will discuss the drivers and needs of telecom change in the utility sector.
Thank you, Jonathan. After understanding the global communication trends, let's see how they are related to the energy sector. There are several drivers for the energy sector to modernize the infrastructure. Some of these drivers, like smart grid and regulation, are unique to the sector, while for others, like security and aging networks, they have their own unique flavor. Let's spend a minute on these drivers and understand their implications on the telecom infrastructure. So starting from the aging networks, globally, it is already a fact that packet-based equipment is the new standard for transport networks, replacing the aging TDM-based equipment. Since utilities usually don't experience the urgency from demanding applications to force them readjust, the shift to packet is usually a bit slower than the global trend. However, we reached a point in time that operational issues like spare parts, maintenance, experienced personnel, as well as new applications and equipment are forcing the utility companies to transition to the lower cost and globally used packet technology. So even though in many cases the existing TDM-based transport fits well with current requirements, the change is inevitable. Second is the smart grid. As you well know, smart grid deals with two key issues. The first is enhancing the grid automation to increase network efficiency and service continuity. This is done by enhancing and expanding the control network to the distribution and all the way down to the end user facilities through smart meters. The second is to become greener and reduce the carbon footprint by using renewable energy resources and by increasing the network efficiency. The impact of these issues on the requirements from the communication network is substantial because the communication network is the enabler of the grid to become smart. So if, for example, new wind turbines are added to the grid, new communication links that are able to control them are required. Similarly, to best utilize the new control and automation capabilities, more information is passed through the network, and therefore a higher speed communication network should be in place to support them. The third driver is increased regulation. There are a few areas where regulation impacts the telecom infrastructure. One is increased competition. One area of competition in the energy is the energy sector service domain, where in some countries the grid is separated into generation and into transmission and distribution. Another area of competition encouraged by the government is the national telecom market. In this case, the government allows and encourages the utilities to leverage the infrastructure and right-of-way to become players in the telecom market, also known as utelcos. In both cases, the telecom impact is built out of new scalable networks that are ready to grow to meet future requirements, but without the need to invest now in capabilities that will be required at a later stage. Another area of increased regulation is security. Whether owned by the government or privately held, utilities are considered a national critical infrastructure. A major power outage is the nightmare of every executive in the energy sector. Every aspect of our life is dependent on continuous energy supply, and the implications of a major failure can be catastrophic. Last but not least is the cybersecurity. A few examples collected from the press will explain everything. As you can see, cyber attacks on strategic industries are not a futuristic scenario, but a day-to-day reality all over the world. In a recent survey conducted among companies responsible for the power, water, and other critical functions, 70% of them reported at least one security breach that led to the loss of confidential information or disruption of operation in the last 12 months. A similar view is presented in a graph on the left-hand side, showing that the energy sector specifically reported the highest number of security breaches incidents. As many more incidents were either not detected or not reported, it is clear that there is a real threat that must be eliminated. As a result, governments are increasing the security requirements for utility companies in general and for their communication networks in particular. This is because penetrating these networks opens the door to access the entire utilities infrastructure. The shift to packet technology increases the threat, since packet technologies are more vulnerable to such attacks. For example, packet technology like IP, which is based on a dynamic and distributed control plane, increases the risk of a cyber breach, as well as the potential damage if such a breach occurs. In addition, to support new smart grid sensors, communication equipment is expanded to new locations, which in many cases are unmanned and less secure, again increasing the danger of breaking into the network. To address these challenges, new security means are deployed, from perimeter security like video surveillance cameras, through deep packet inspection, DPI for SCADA, and up to encryption at various layers. So to conclude this part, the telecom changes resulting from the drivers that we have reviewed are the following: high-speed, reliable, and scalable packet optical-based communication networks. Before we move on to review the unique challenges that utilities companies are facing, we would like to hear your view on that via the following poll question. So the second question we would like to ask you today is, what do you see as your greatest challenge in transitioning your network to packet? The options you can choose from are service resilience and packet reliability, updating or training personnel on packet technology, security issues which add more complexity, the mix of new and legacy elements makes network management complex, or other challenges that were not included in the list. So let's wait for a moment to allow you to submit your responses before we move on to see the results. I would like to take this opportunity and remind you that you have the Q&A tab at the bottom, and you are more than welcome to use it and send questions to us that we will try to address by the end of the session. So I hope that by now you have the time to vote on the various options, and let's move on to the results. So we can see actually a very, very clear answer here is that you see the mix of new and legacy elements as your greatest challenge, the complexity that it adds to the network, followed by the training of the personnel on packet technology. These are very, very interesting results for the second poll question. So, based on our vast experience in the industry, and without, of course, any previous knowledge of the results we just reviewed, we summarized utilities' unique challenges as two. The first, and the one that evolves them to an up-to-date infrastructure, is risk-free transition from TDM to packet. As a mission-critical infrastructure, there is no room for mistakes, and we must get it right the first time. The second challenge is how to build a network that is future-proof and can evolve to meet future needs on one hand, but without unnecessary upfront investments on the other. Now let's have a look at the details of each of these challenges. In order for the transition to packet to be risk-free, there are several aspects that need to be addressed. The first one is how to maintain utilities' strict service requirements in terms of performance, like bandwidth, jitter, and latency, and also in terms of service availability, like protection and restoration. The second aspect is that networks are becoming more complex. The transition of SCADA equipment to packet is gradual and slow, and therefore there is a need to support a mixed TDM and packet SCADA environment for the coming years without any degradation in performance. In addition, packet-based networks are more complex and sophisticated than TDM networks, and therefore may require new expertise from the personnel responsible for the network. It is a particular challenge for a non-telco organization whose core business is not communication. The third aspect is security. As mentioned before, the shift to packet technologies, which are more vulnerable to attacks, together with the expansion of the network to many more locations driven by smart grid, increase the risk of security breaches. The second key challenge utilities are facing is future-proof evolution. This means that the network should be scalable to meet future traffic capacity and services, whether from internal sources like new sensors, or to support requirements derived from becoming a utelco. The challenges here are obviously not just technical, but economical as well. Specifically, the ability to support future-proof evolution cost efficiently. To learn how we address these unique challenges at ECI, I'd like to return the microphone to Jonathan.
Well, thank you very much, Gil, for summarizing what is driving change in utility telecom networks and the major issues that solutions need to address. Now let's examine how ECI is approaching this. And again, I'll remind you, please use the Q&A tab at any time during this session. The name of ECI solution is ElastiGrid. ElastiGrid is ECI's next-generation packet optical telecom solution for mission-critical utility networks. It encompasses both aggregation networks and a backbone network. The aggregation networks gather and distribute traffic from the power generation sources and the numerous substations. The backbone network provides high-speed connectivity among the aggregation networks. The backbone network can also easily do double duty to handle external traffic in the scenario where a utility acts as a traffic wholesaler or a utelco. Also of particular note, ElastiGrid provides centralized, consolidated, end-to-end network management across all of its elements, simplifying operations for the utility. As we will examine in the coming charts, key attributes of ElastiGrid are: it supports both legacy and packet protocols on the same equipment, directly addressing the issue of risk-free network transition. And by design, it is scalable, flexible, multi-service, and future-proof. ElastiGrid is built on SmartLight, which is ECI's framework for elastic network solutions, hence the name ElastiGrid. Sitting at the base of SmartLight are converged layer 0 to layer 3 packet optical transport systems with virtually unlimited capacity. These are managed centrally, end-to-end, through the LightSec network management system for point-and-click service creation. Light apps are value-added applications, which are designed to run both on the installed base as well as under a software-defined networking, or SDN architecture. Examples of light app applications are network analytics, which provides dashboards on what network resources are being over and underutilized, and bandwidth on demand for dialing up optical paths on short notice. Light apps can be a very useful resource for utilities looking to enter the utelco business to obtain a competitive edge, particularly since these types of applications are also being used by telecom service providers. A full SDN model with real-time multi-layer control of the network equipment will be achieved through the Light Control SDN controller. Now, wrapping all of SmartLight in a security cocoon is LightSec, the LightSec security suite that protects both transport paths and operational integrity, and we will hear more about that later. Here is a quick overview of ECI's NPT and Apollo packet optical transport system product lines that underlie SmartLight and the ElastiGrid solution. NPT is a packet transport system with integrated optics, and typically for utilities it is a best fit for aggregation networks. Apollo is an optical transport system that also supports packet services, and its typical application is to form a high-speed backbone network. These two systems can work seamlessly together under a common network management system and can construct any access through core packet optical transport application for utility network needs. Now, besides complete access to core coverage, as we showed on the previous chart, here we summarize the rich range of services, technologies, and transport capabilities supported by NPT and Apollo. For example, these systems provide transport from multiple layer 0 through layer 3 services, including carrier Ethernet, which is being certified by the Metro Ethernet Forum, and layer 3 virtual private networks, as well as optical, video, and legacy TDM services. These systems use multiple layers of transport technology, extending from DWDM optical paths to MPLS and IP packet paths. They support transmission speeds from lowly 64 kilobits per second, which you might use for your SCADA interfaces, to over 100 gigabits per second for high-speed backbone networking. And they can scale switching capacity from several gigabits per second to over 16 terabits per second. The key benefit, perhaps, of NPT and Apollo is that they integrate all this transport functionality in converged common platforms. This simplifies network planning and deployment, since you do not need to use separate platforms for your legacy and your modernized networks. Now let's go a level deeper and examine in more detail how ElastiGrid delivers risk-free and future-proof network transformation. We start by looking at how to achieve predictable traffic performance. The issue here is, how do you extend Ethernet local area networks into the wide area across your aggregation networks? This is an issue because Ethernet and packet networking is by definition statistical and not connection-oriented. In other words, Ethernet by itself does not guarantee predictable performance. So perhaps your major decision in modernizing to a packet network is how to achieve the same level of predictable connection-oriented performance as you have grown to know and love with your TDM network. ElastiGrid's answer is to use MPLS TP, which we believe is far and away the best solution. The TP stands for Transport Profile, because this protocol was designed to provide traditional transport network performance or packets. MPLS-TP takes a core feature set from IP MPLS, discarding all the heavy-duty routing features, and extends this core with transport attributes, such as bidirectional paths and a separate control plane. The result is an ability to set and guarantee the performance of your packet transport connections even before a circuit is turned up. It also provides a rich end-to-end operational visibility, and perhaps best of all, in the event of a link failure, it can provide the identical sub-50 millisecond restoration that you are used to with your TDM networks. Now, under risk-free transition, your network needs to continue to have the highest level of service assurance, quite possibly 4 nines availability. Elastic Grid addresses this on many levels. Network equipment itself is deployable with full redundancy if is required, and in addition, because the equipment frequently needs to reside near high voltage power transmissions, it has been tested extensively for electromagnetic compatibility and extreme out-of-door environments. At a network level, there are many options for path protection in the event of link failure, from automatic protection switching for individual links to dynamic path restoration across multiple nodes, as illustrated in the example on this chart. In fact, 2 types of restoration can be engineered: for individual services within an optical path, or you could even restore and reroute entire optical wavelengths carrying multiple services. And at the level of the end-to-end management system, or management systems, Elastic Grid supports automatic remote data replication and recovery, enabling full off-site data backup. Now, SCADA devices are the eyes, ears, and fingers at the periphery of your utility grid. An issue you may well be facing is that your programs to modernize your SCADA devices and the programs to modernize your networks may be taking place asynchronously. You may have a solution where there is old TDM interface SCADA, but the surrounding networks are moving quickly to packet. Or the opposite. You may be investing in new IP SCADA, but at the same time the surrounding networks are still TDM. The good news is that with Elastic Grid, you do not need to choose. Elastic Grid network elements can mix and match transport of both new IP and legacy TDM SCADA interfaces on both new packet and legacy TDM networks. So you have one less transition headache to worry about. Now, security is an increasingly important as networks incorporate open interfaces and programmability. This is perhaps even more important for utility networks that, as we saw earlier, are and continue to be the frequent target of attacks. Elastic Grid solution is the LightSec cybersecurity suite that provides holistic protection for all layers of communications. Its key elements are: it supports layer 1 through layer 3 encryption, in particular featuring layer 1 optical encryption using a standard called AES 256 GCM, which in effect makes the optical fibers virtually impregnable to tapping. It supports a secured site gateway implemented by an NFV, or Network Function Virtualization module, which provides multiple security engines for unified threat management. It supports strong authentication. This guarantees user identity, and it can also be supplemented as users are logging on with session monitoring and recording capabilities. It has a unidirectional secure gateway for classified networks that want to share information with less secure networks, which may well be the case in the utility sector. And the last two are very interesting. It supports something called anomaly detection which detects early breaches that usually precede major attacks. This has been studied extensively by our security team. You often do get early warnings. And in a similar vein, it supports big data cyber analytics, which analyzes the behavior of users to identify trends that may indicate malicious users in advance. Pulling this all together, because there's so many different security options, and you also may also have your own, is a product called LightSec Viewer. This is a smart, web-based threat management system for managing and visualizing cyber solutions. The LightSec Viewer provides a centralized, aggregated view of threats from multiple security engines, again, from what's supported by LightSec and also third-party, which you may be deploying today, providing a holistic view of threats and facilitating configuration of the protection suite to match your specific needs. Expanding on one element of the previous chart, one innovative way that ElastiGrid implements security elements is using network function virtualization, or NFV. One way to think of NFV is as a modular programmable platform that implements via software functions that previously relied on dedicated hardware. ElastiGrid has an NFV engine that can be configured either as a pluggable within ECI's equipment or as a standalone module. It can run software from Checkpoint as well as other security software to provide both a SCADA protection suite and a general protection suite, including many of the functions that were listed on the previous chart. The modularity offered by common NFV platforms reduces both capital expenditures and operational expenditures, and is a very important telecom trend within the general telecom space that I'm pretty sure you'll be seeing within the utility telecom sector as well. Now, one area where ElastiGrid truly differentiates is through its exercise of centralized end-to-end visibility and control. The LightSoft network management system, which you see a screenshot above, provides intuitive point-and-click provisioning and monitoring across the entire network, covering multiple service layers and mixes of old and new technologies. LightSoft's broad coverage is particularly beneficial for effortless end-to-end service creation, as it eliminates the requirement to set up a service segment by segment or technology by technology, depending on the underlying systems and technologies. Now, another aspect of centralized visibility and control, as we mentioned before under Smart Light, is Light Apps. This component provides value-added applications like bandwidth on demand and network analytics that gather and report detailed information on network utilization. Here we see a very high-level view of a network analytics screen before we drill down into details. I'm not showing the drill down here, but when you have Light Apps, you can drill down. This application provides the business intelligence so you know where your network is either running into bottlenecks or where you can find idle capacity. Until now, we've been discussing how to handle risk-free transition for a legacy TDM to a modernized packet network. Equally important is how you grow this network to meet your future needs. ElastiGrid can accomplish this in several ways. For example, a common expansion unit can be used with access, aggregation, and core platforms to perform unique in-service expansion of port fan-out and other features such as SCADA interfaces. ElastiGrid also provides a host of other capabilities for smooth growth. For example, it supports software upgradable Ethernet clients on the same card for smooth evolution from 10 gigabit Ethernet to 40 gigabit Ethernet to 100 gigabit Ethernet client interfaces. So you don't have to change your hardware as you're growing your client capacity. At the same time, the packet switching fabrics and the optical optical transport network switching fabrics also scale smoothly across a wide range, allowing you to grow solutions on existing equipment as traffic grows. Besides being expandable and scalable, ElastiGrid is also future-proof in its ability to support a wide range of services and service features, so you can be ready for future technical requirements and future business opportunities. This covers a mix of client services mapped over both Ethernet MPLS and OTN DWDM networks, and includes, for example, timing synchronization for wireless access, storage interfaces for data centers, high speeds for backbone networking, perhaps as a utelco, and even a capability to support lambda or wavelength services. So it extends all the way from your SCADA 64 kilobit per second interfaces to the kind of high-speed interfaces that we're commonly seeing right now for data center interconnection, up to 100 gigabits per second. The icing on the cake from ElastiGrid is that ECI is much more than just a supplier of packet optical aggregation and backbone networks. ECI's integration division works with a range of third-party planners and partners to provide utilities with a one-stop shop for an integrated end-to-end solution. This covers wireless access, perimeter security, unified end-user communications, IP switching and IP routing, management automation, and even complementary activities like civil works. Most important, when we say integrated, it means that all multidisciplinary technologies are tested and proven to work with one another. In fact, ECI can provide a complete turnkey solution. So, in summary, we would like to answer the question, why ECI? It starts with ElastiGrid that offers a complete solution for modernizing utility aggregation and backbone networks under end-to-end network management with point-and-click service creation. Moreover, ElastiGrid enables risk-free transition from TDM to packet networks, which we saw from the poll question, at least for this audience, is the leading issue that needs to be addressed, and support scalable, future-proof evolution. Moreover, ECI has a proven track record with hundreds of customers, including well over 100 utility customers. So this wraps up the formal presentation. And now we can move on to responding to questions that have come in. I'd also like to note that the contact information for Gil and myself are on the screen. If anyone would like to contact us afterwards for any follow-up questions. So I will now hand the microphone, if you like, back to Chance, who will moderate the Q&A.
Thank you very much, Jonathan. So as Jonathan mentioned, the contact details for both of the speakers are on the screen, or you can also contact them directly by using the purple Contact Us widget at the bottom of your screen. Before you leave today's session as well, if you could also leave your feedback in the red survey widget, and we'd greatly appreciate that. So we've already had some questions in, so we're going to dive straight into these now. So the first one I've got for you here is, does encryption involve additional blades, or is it part of the basis chassis or switch card?
I'm sorry, could you repeat that again, please?
Yes, sure, no problem. So, does encryption involve additional blades, or is it part of the basis chassis or the switch card?
It depends. There's a number of solutions that we support for encryption. For instance, on the layer 1 optical encryption, that's supported as part of our 10G optical transport solutions today, and in the future will be extended to the 100G line rate. If we're talking about other types of optical encryption, such as layer 2 optical encryption and layer 3 optical encryption, or not optical encryption, but layer 2 encryption, and things such as layer 3 encryption, such as IPsec, those would be supported through the NFV module that I talked about earlier, and to other appliances that ECI can make available. So it really depends on the type of encryption that the person is looking to support.
I'd just like to maybe to add to that in general our approach or our architecture is modular. Encryption is not required in every location, and therefore we usually support it through pluggable module or a standalone module. This is another option, but not as an integrated part of the base unit, because again, it's not required in every location, and you want to pay for actually only for what you actually need, and not for features that may be required in other locations.
Okay, excellent. Thank you both for your response to that question. So if I move on now to our next one, it says, why can't Ethernet be used for network transport?
Okay, maybe to answer that, it's we need to get a little bit back in history. Basically, Ethernet was born for use in LAN networks. It was later expanded to the WAN in order to cut the costs. However, Ethernet or native Ethernet is lacking transport attributes like deterministic performance, like reliability, meaning carrier-grade protection schemes, easy operation and troubleshooting, like transport people used to have in the TDM world, service OEM, and also support of legacy services. Now, many of these drawbacks were linked directly to the connectionless nature of Ethernet, which cannot be overcome unless the networks are extremely over-engineered. So MPLS-TP or MPLS transport profile was designed in order to make Ethernet carrier-grade, overcoming the transport gaps that I've just mentioned. So it is a connection-oriented, it provides predictable performance, and it has extensive OEM and legacy services support.
Okay, perfect. Thank you very much there, Gil. So if I move back on to our other questions we've got in, this one is, do you really believe utilities need ultra-high capacity and high-speed interfaces?
High-speed capacity and high-speed interfaces. Okay, I'll take this one, Chance. I guess the answer is it depends on your network. I mean, certainly in the telecom world, it's developing transmission capacities, switching capacities that may be in excess of what a lot of utility networks need. But certainly putting in place the kind of backbone capabilities that can upgrade to these kind of capacities would probably be very useful. Even just for the initial aggregation or initial transport of the traffic from your aggregation networks, particularly if you're going to be connecting to certain corporate utility data centers that you have, you're probably going to have a need for higher speed transmissions. And in the case, if you're looking to expand your business to being a traffic wholesaler or utelco, you probably also can make benefit of these higher speed interfaces. So I think our position at ECI is you may not need all the kind of capacity upfront that would be perhaps be seen within the telecom world, but certainly putting in place the kind of backbone network that can support these, you'll have some initial needs for that today, and it will certainly give you the capability to upgrade for that in the future.
Excellent. Thank you very much, Jonathan, for your response there. The follow-up question is, can you expand on how SDN is relevant for the utilities network?
Okay, SDN. SDN is software-defined networking. This is something which is actually one of the hottest topics, if you like, in the telecom world today. And it's something which is evolving from the data center world now into the wide area network. Under a true and sort of visionary type of SDN view, what's going to happen is we get true separation, if you like, of the control plane taking place within the network elements. And this will be controlled by something called an SDN controller separately, which is software-based, sitting figuratively, if you like, above the network. Certainly, this is the trend taking place within the wide area telecom networks. No one is saying that this transformation will take place overnight. It will take place over several years, and it will lead towards a greater degree of network efficiency. Because of the centralized control and their sort of real-time multi-layer control with the network-wide view that people have with an SDN. And also it will open up the network elements for more quick programming for end-to-end service creation and for the new and innovative service creation. So to the extent that utility networks, just like any telecom networks, needs to support some of those same kinds of features, both in terms of network efficiency and perhaps faster service creation and more flexibility. Buying into this kind of architecture, or at least having it on the roadmap for your utility network, is something which we think is something to keep an eye on. Maybe you don't need to roll that out quite as quickly as they're pushing for in the telecom world, but certainly it's something that you should be looking at in terms of being able to support within the future.
Okay, excellent. Thank you, Jonathan. Okay, so if I move on now to our next question, isn't TDM over packet enough to support legacy?
Well, TDM over packet is a good answer for the scenario in which the SCADA equipment, for example, is still legacy, while the transport network has already evolved to packet. Now, needless to say that this is a good solution if the packet transport network provides the same level of performance and availability as before. This is a mandatory requirement. But assuming this is the case, so this is the scenario that TDM over packet provides the answer to. But there are other scenarios where TDM is still used also for transport in certain domains of the network, and it is either not economical to replace it yet, or it will take a bit longer to complete the transformation. So in order not to be forced to upgrade SCADA equipment because of transport equipment and vice versa, the full hybrid flexibility we described is actually required. So only full flexibility leaves the control over the pace of the change at the utility hands. And this is a very important feature or capability to control the pace of the transformation and not to be forced to upgrade equipment because of changes in technology of another type of equipment.
Okay, thank you, Gil. That's a great response there. So if I move on now, our next question is, how does ECI security integrate with other security solutions that we already have?
I'll take this one, Gil. The main integration takes place through the LightSec viewer. I mentioned that before. What it does is it enables to take inputs from a variety of security sources, compiles, aggregates, does some degree of cross-checking, and then provides a unified view of all the different security solutions. So security is fairly complex subject. There's many solutions that can be done, but using the LightSec viewer, you do have the opportunity for an aggregated view of that. So there's nothing stopping customers from providing a variety of different solutions and then getting a unified view through the LightSec viewer.
Okay, perfect. Thank you. We've just had another question come in about SDN as well. So the SDN implementation, is it an ECI only solution, or does it support communication with other vendor equipment as well?
SDN is a general industry framework, and the move within our SDN solutions is to support open interfaces on our network equipment that they will be able to be controlled by other SDN controllers, and certainly within an SDN framework, as will be implemented within the general SDN structure, the SDN controllers themselves are sort of pulled together by an SDN orchestrator, and 100% the SDN controller that ECI is deploying will be available for orchestration under that sort of general framework. So if you're going to do SDN, you really do need to buy into the overall openness and the ability for multiple sets of equipment to be controlled. At the same time, we expect to be able to control other parties' equipment. The other thing I'd like to add about this is that the LightApps suite that I talked about before, which provides a lot of what you might want to call the SDN app. Well, these are the SDN type applications and SDN value add. These can be run right now on ECI's equipment without even waiting for a full SDN infrastructure, which could take several years and will take several years across the industry to roll out. So initially, we'll be running those applications through our LightSoft NMS, and then using the same interfaces, we will port them over as it becomes available to a full SDN infrastructure under the SDN controller.
Okay, thank you very much. It looks as though we've only got time for one more question, unfortunately. So if we haven't got round to answering your question in this Q&A session, then your question, along with your contact details, will be forwarded on to our speakers, and you will receive a response in due course. So our final question for today, then, is for distribution power utility, which technology is preferable from switching TDM to MPLS IP or MPLS TP?
Okay, so I think we've touched this topic a bit during the presentation. So first, of course, TDM switching is a very good technology, reliable technology. However, it is a legacy technology, and again, the shift from TDM to packet is something we cannot avoid, even if the TDM technology still fits well the current requirements. So we need to shift to packet. Now, regarding whether using IP-MPLS or MPLS-TP, again, we touched it a bit. MPLS-TP has some unique advantages built into it in order to have deterministic performance, in order to have extensive OEM, ease of management, reliability, special features that were put into MPLS-TP as an extension of the IP-MPLS, so it will fit better to transport networks, and this is the case also for the distribution network. So all in all, we recommend the MPLS-TP technology for the distribution as well.
Excellent, thank you, Gil. Just before I conclude today's session, Gil or Jonathan, do you have any final thoughts you wish to share with the audience?
The final thought that we have is, first of all, thank you all for giving us your time to listen to this webinar today. To the poll questions that we've put together, it sort of supports our view of the industry, both in terms of the pace of network transition, and certainly even more so on the major challenges that you're facing for your network transformation. And speaking for myself and for Gil and for the whole ECI team here that's been supporting us, if you have any questions, again, please do feel free to contact us directly through the emails that we've provided to you on the screen. Gil? Okay, well, thank you very much.
So that just leaves me to thank Jonathan and Gil for what was a great presentation, and thank you to ECI Telecom for sponsoring today's session. To the attendees, you will receive an email shortly telling you how you can access the on-demand version of this webinar, or you can access this through our website, which is www.business-review-webinars.com. Please continue to ask questions, vote in the polls, and interact with the widgets as the on-demand version remains interactive. We look forward to sharing further webinars with you, so please do keep an eye out on the website just mentioned and follow us on Twitter at BRWebinars for daily updates, and join our LinkedIn group Business Review Webinars. So thank you all for attending once again, and I hope you all enjoy the rest of your day.